Hi, in this video, I will be showing you problem number 5 of chapter 11, section 5. Test the series for convergence or divergence. Sigma, n varying from 1 through infinity, negative 1 to the exponent n minus 1 divided by 7 plus 8n. Obviously, this series is an alternating series because it has negative 1 to the power of n minus 1. So when you plug in n equal to 1, you get positive. When you plug in n equal to 2, you get negative. So positive, negative, positive, negative, the signs alternate. So it is an alternating series. So it makes sense to apply alternating series test. So what is alternating series test? If the alternating series sigma negative 1 to the power of n minus 1 bn, if you expand it as b1 minus b2 plus b3 and so on, where the sign changes alternatively from positive to negative, then all the bn's are all positive. So without the sign, they are all positive terms. If it satisfies condition 1, which is bn plus 1 less than or equal to bn for every n, meaning the sequence bn is a decreasing sequence. This means the sequence bn is decreasing, and limit is n approaching infinity bn equal to 0. If it satisfies these two conditions or requirements of this for this alternating series, then the alternating series would be convergent. That's what the alternating series test says. So we have to establish these two conditions for the series that is given in our problem. So we will find out. We will express the given series, just sigma n varying from 1 through infinity, negative 1 to the power of n minus 1 over 7 plus 8n, as sigma n varying from 1 through infinity, negative 1 to the power n minus 1 bn, where bn equal to 1 over 7 plus 8n. Obviously, for all n more than or equal to 1, this is going to be positive. So the terms are all, without the sign, the terms are all positive. And then we should also establish the first condition, which is the decreasing nature. In this case, it's easy to establish the decreasing nature of the sequence. All we have to do is consider bn plus 1, which is 1 over 7 plus 8 times n plus 1, which is 1 over 7 plus 8n plus 8. If you distribute the 8, that's 1 over 8n plus 15. So we notice here 8n plus 15 is obviously more than 8n plus 7. Or if you take the reciprocal, 1 over 8n plus 15, and then if you take the reciprocal, the inequality gets reversed. It's less than 1 over 8n plus 7. So this is the term corresponding to n plus first, and this is the term corresponding to the term 1 over 7 8n plus 7. So bn plus 1 is less than or equal to bn for all n. So this is hypothesis 1. So condition 1 is satisfied. And we should also do the second condition, which is the limit as n approaching infinity bn equal to 0. So let's consider limit as n approaching 0 of bn. Which is limit as n approaching infinity of 1 over 8n plus 7 or 7 plus 8n. So as n is very large and the numerator is only a constant, in the denominator it becomes infinity, numerator is a constant, so constant over infinity, that becomes 0. So condition 2 is also satisfied automatically, is satisfied as well. So we have actually established the two conditions that are required for this alternating series to be convergent. So by alternating series test, we conclude that sigma an, which is the alternating series, sigma -1 to the power of n minus 1 over 7 plus 8n is convergent. Hope this video helps.